Good day, math buddies! For this video, we will be learning all about mathematics. So just buckle up, relax, and all together, let's learn in an interesting and exciting way. For today's video, we will be aligned with this objective. We will solve quadratic equation by extracting square roots. In our previous video, we were able to determine and define quadratic equation as a mathematical sentence of degree 2, written in standard form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. So there are 4 methods used in solving a quadratic equation. 1 is by extracting square roots. Second, by factoring. Third, by completing the square. And fourth is by using a quadratic formula. But we will be focused on today's discussion, and that is by extracting square roots. The question is, where can we use extracting square roots in solving roots of a quadratic equation? It can be utilized in the form x squared equals k, where k is a real number. Among the examples of x squared equals k form of a quadratic equations are 3x squared equals 27, x squared equals negative 15, 5x squared minus 125 equals 0, 2x squared plus 18 equals 36, negative x squared equals 100. In short, this form of a quadratic equation can be written as ax squared plus c equals 0, meaning the given terms are the quadratic term and constant term. With that, can you cite 5 examples of a quadratic equation in the form x squared equals k? It is your turn. So in extracting square roots, let us try to focus on these insights. Quadratic equations that can be written in the form x squared equals k can be solved by applying the following properties. First, if k is greater than 0, then x squared equals k has 2 real solutions or roots. X is equal to positive negative square root of k. Meaning, if our k or our constant is positive, we will be expecting to have 2 real solutions or roots. Second, if k is equal to 0, then x squared equals k has 1 real solution or root, and that is x is equal to 0. Third, if our k is less than 0, then x squared equals k has no real solutions or roots. Meaning, if our constant is negative, then there will be no solutions or roots in our quadratic equation. How do we solve quadratic equation by extracting square roots? Let's have our example number 1. 5x squared is equal to 125. In solving our quadratic equation by extracting square roots, we must remember that the coefficient of our quadratic term must be equal to 1. Hence, in this given, our a in a quadratic term is equal to 5. So we need to eliminate this by dividing both sides by 5. So dividing both sides will eliminate it on the left side. The quotient of 125 and 5 is 25. Here, we are now provided with our x squared equals k form, where 25 represents our k, and 25 is a number greater than 0. Earlier, we determined that if k is greater than 0, it follows that we will be expecting to have two real solutions. So by extracting square roots, we will determine the value of our x, which is equal to positive negative 5, for the reason that 25 is a perfect square, and the number multiplied by itself to obtain 25 is 5. Therefore, we can determine that this equation has two real solutions. Let's have example number 2. 2x squared plus 7 is equal to 39. This form is not yet written in x squared equals k. So what will we do? We need to get rid first of the constant 7 on the left side of our expression using subtraction property of equality, meaning we will subtract both sides by 7, eliminating 7 on the left side, leaving 2x squared equals 32. 32 is the difference between 39 and 7. But then again, this form is not yet in x squared equals k because we still have 2 as the numerical coefficient of our quadratic term. So we need to get rid of it by dividing both sides by 2. Therefore, we will have x squared equals 16. Again, 16 represents our k, and our k is greater than 0, so we are expecting to have two real solutions. Applying extracting square roots, x therefore is equal to positive negative 4. Meaning to say, the two solutions are x is equal to positive 4 and x is equal to negative 4. Let's have our third example. 3x squared minus 2 equals 7. In this case, we need to get rid of negative 2 on the left side of our equation. Using addition property of equality, we will add both sides by 2. Therefore, the result would be 3x squared is equal to 9. This form is not yet written in x squared equals k form because we still have 3 as the coefficient of our quadratic term x squared. So we need to divide both sides by 3, obtaining x squared is equal to 3. In this form, 3 is our k, and k is greater than 0, so we are expecting to have two real solutions. So applying extracting square roots, x therefore is equal to positive negative square root of 3. Unlike in our previous example, 3 is not a perfect square, and it has no factor where one is a perfect square and the other is a non-perfect square. So we will have our final answer as square root of 3. Therefore, the solutions are positive square root of 3 and negative square root of 3. Let us proceed with our next example. X squared plus 27 equals 27. So we need to get rid of 27 on the left side of our equation. Using subtraction property of equality, we will subtract 27 on both sides of the equation. The result will be x squared equals 0. This is now in x squared equals k form, where k is equal to 0. Earlier, we determined that if our k is equal to 0, it has one real solution. Applying extracting square roots, x is equal to 0. And that is correct. One real solution. The value of our x is equal to 0. For the fifth example, x squared plus 100 equals 0. So in this form, we need to write into x squared equals k form using subtraction property of equality, subtracting both sides by 100. The result would be x squared is equal to negative 100. This time, k is less than 0. So we will be expecting to have no real solutions at all. By extracting square roots, x therefore is equal to square root of negative 100. So there is no number multiplied by itself. The result will be a negative answer, just like negative 100. Therefore, there will be no real solutions or roots for this equation. Let's have the next example. Quantity of x minus 3 squared is equal to 25. In this form, we will apply directly extracting square roots. Simplify, x minus 3 is equal to positive negative 5. In this case, we need to get rid of negative 3 on the left side of our equation. Using addition property of equality, add both sides by 3. The result will be x is equal to positive negative 5 plus 3. So we need to separate the positive and negative symbol. So we will have to obtain two possible solutions. The first one, x is equal to 5 plus 3. That is for positive 5. X is equal to negative 5 plus 3. That is for negative 5. So let us simplify our linear equation. X is equal to 5 plus 3. The result is x equals 8. While x equals negative 5 plus 3, the result is x equals negative 2. So again, our k is greater than 0, so we will obtain two possible roots or solutions, 8 and negative 2 in this case.